to see my screen? Great. Hey, good evening, Rahul. Yes. So we'll be starting in one minute. All right, guys. So let's get started. So today's topic of discussion is Hive. So yesterday we completed with Pig. So just to quickly tell you, so Pig was a framework which was developed by Yahoo. And why this was developed? Because not everyone know how to write a Java MapReduce code. So with Pig, it was possible to use any other language which ultimately converts to MapReduce and processes your data which is there on HDFS. Similarly, so there are other companies. So if you talk about reporting tools, okay. Now, how do reporting tools create any reports? They usually connect to a database, right? They connect to a database, they trigger a few queries, and the output they display that as a report. Now, if my data is there in HDFS, if my data is there in Hadoop, how will I enable all my reporting tools to create reports? So this is where Hive stepped in. Now, at a very high level, what is Hive? So again, Hive is also a language layer, which is basically giving you a capability of triggering and writing SQL queries on top of your HDFS, on top of your MapReduce. So basically, what is Hive? So if this is your HDFS, this is your yarn, this is your MapReduce, this is your Pig, here comes your Hive. So basically what Pig was doing, Pig was taking a input as a language which was called as Pig Latin. What was the responsibility of Pig? It used to convert the Pig Latin to a MapReduce job, a Java MapReduce job, which it used to submit on the MapReduce cluster, which ultimately goes through yarn and processes your data which is there on HDFS. Hive is on the same lines. The only difference between Hive and Pig is now Hive accepts SQL. All right, and this SQL, it's very similar to your normal MySQL language. So you have many databases, right? You have Oracle, you have MySQL, you have SQL Server. All of these have small changes in their SQL language. So Hive SQL is very similar to your MySQL. All right. So what Hive does? So again, guys, don't misunderstand Hive as a database. Hive is not a database. It is just a language layer. It converts SQL to MapReduce. That's it. It is not acting as a database. All right. Any doubts in Hive? What Hive is doing? Why Hive? What is the responsibility of Hive? Yes, Manish. Yeah, so Manish has a question. So Pig and Hive or Java does the same thing. Yes, Manish, it does the same thing. It is just different ways of doing the same thing. So the basic reason for developing these tools like Pig and Hive was because Hadoop is actually a combination of your database people and your programmers. Your database people does not know how to code, all right? They cannot code a Java program. They cannot code a Python program. They just know SQL. So this is the reason Hive was developed. Okay, Chaitanya has a question. So basically, it is used to process files in HDFS. Yes, Chaitanya. So it's same. It's ultimately it's MapReduce. If you write it in Pig, if you write it in Java, if you write it in Hive, ultimately it's MapReduce. Okay, it's just layers which is converting your other languages ultimately to a MapReduce job. Okay. So again, so nowadays in companies, no one actually codes at the level of a Java and Python for writing MapReduce jobs. Everyone uses these frameworks because it reduces your development time a lot. So if I want to do a complex, logic, if I want to implement a complex program, it's very difficult, it's very time consuming to code it, to optimize it using Java MapReduce. So what organizations do nowadays is they go with other languages. They use Hive, for example, they use Pig. Now these tools, though it is simplifying your life, it is giving you additional features. For example, Hive exposes a JDBC connection through which you can connect your reporting tools. Right? So your existing reporting tools will run unchanged on your normal MySQL database also and on your Hadoop also. That's the advantages with these frameworks. Right? So before just starting into the presentation, so just let me tell you high level some features about Hive. So though like Hive is an SQL layer, right? So though it is SQL, for using it, it is very simple because it's just like a normal database. You would when you'll be using Hive, you will get the feeling like you are using MySQL. But the underpinnings, the architecture internally for Hive versus your traditional database, it's very different. Can anyone tell me if I write a query in MySQL, right? How does internally that query is processed by your MySQL engine? What it does internally? How it finds the data internally? Anyone have any idea on this? So Minesh says it converts to code. No, Minesh, MySQL does not convert to code. It's basically an engine which uses binary tree algorithm, all right, to find your data from the disk. Okay. So my data is managed in blocks. It uses a B tree algorithm, all right, binary search tree algorithm to fetch your data. On the other hand, Hive is very different. All right. The reason is Hive is not a binary search. Hive is a MapReduce. All right. So let's say I have employee records. Okay. Let's say I have a file which contains 1 million employees. I'll just open a notepad. Right. So I have a file which contains 1 million employees. Okay. On this file, let's say this is stored inside a table. My table name is EMP. All right. If I want to find a specific employee ID, what query I would be using? I would be using select star from this table where employee ID equal to, let's say I want to find the employee ID 15,000. Right? How much time will your MySQL take to return the output for this query? Ideally, how much time this will take to trigger this query? Right? Yeah. So Chaitanya says milliseconds. Okay. Because Bhaskar says milliseconds, Chaitanya says it will be quick. Right? Rahul says 15 minutes. Why 15 minutes? Why this number? No, so Rahul says it's huge data. So it doesn't matter. 1 million is very small for your MySQL database. It's not a very huge number. Right? So the right answer is it will be taking around somewhere between milliseconds to 1 to 2 seconds, not more than that. Okay. On the other hand, right, the same query unchanged will run in Hive also. All right, but Hive will take a lot of time to process this data. The reason is Hive is triggering a MapReduce job. Now, how MapReduce would be processing it? MapReduce would be breaking this file into blocks. Correct? Let's say it made say 5 blocks. All right, so it would be writing 5 mappers. Does it require a reducer? I'm just selecting star. I'm not doing any aggregation or something, so it does not require a reducer. All right, so it would be triggering 5 mappers. Now what my mapper is doing, my mapper is reading data line by line from the block. Correct? So what a mapper's overall 5 mappers will do, it will start reading the data line by line. So it will read the first line. Okay, it will check if the employee ID is 15,000. No, it will go to the second line. It will check is employee ID 15,000. No, third line. Similarly, it will go until 15,000. All right. At the row 15,000, it will check is the employee ID 15,000. Yes. It will give me output for this particular line. Now, what do you think? Will after giving this output of 15,000th employee, will my MapReduce stop? Right, so Bhaskar says no, it does not stop. Rahul says it should not. And the right answer is it will not stop. Okay, because for my MapReduce, it is, so understand MapReduce is basically, it's a batch processing kind of a framework. It processes your entire file. Okay, it will process your entire file. So this means when it gets the employee ID 15,000, though that's the right output, it will still go to 15,001, 15,002, 15,003, ultimately till 1 million. Though for these particular records, it won't have any output. Actual output is coming only from a single row. All right. So my final output from this query is ultimately a single row. But if you compare with MySQL versus Hive, MySQL will directly go to this 15,000th row. The reason is MySQL uses binary search algorithm. Right. Internally, it manages your data in the form of indexes. All right. So your MySQL will directly go to this 15,000 row, fetch the data, give it the output. What your Hive will do, your Hive will start scanning the data from your row 1 until the end of the file, which is usually termed as Hive does a full table scan. Right? Hive will do a full table scan. The reason is at the back end, the architecture is different. At the back end, it is MapReduce. MapReduce is meant for processing your data sequentially. So it will read the entire file line by line till the end of the file. Right? So that's the main difference between your Hive and MySQL. So if your MySQL is taking, let's say, 1 second, your Hive will take a lot of time. Okay? Your Hive will take a lot of time to get this data. So the latency of Hive versus MySQL, your Hive is a high latency kind of a system. All right, so you cannot use Hive for real-time processing. Right? Overall, Hadoop is not meant for real-time processing data. Right, because it is a batch processing kind of a system. It processes all your files line by line until the end of the file. All right, so Bhaskar has a question. There is no unique index concept in Hadoop or Hive. So Bhaskar, until now, there was no concept of indexes, but with the latest versions of Hive, you have a concept of index, but still that is not as optimized as your MySQL or any traditional database. So even if your data is indexed in Hive, still it takes a lot of time. Right? So it's a newly added feature. So over the period of next Hive releases, this feature may get more and more optimized. All right. Now, what is one more feature of your normal traditional database? So traditional database, what do we usually call it? We call it as an RDBMS, right? Now, what is RDBMS? It stands for relational data. When I say relational data, so you have a concept of constraints. When I say constraints, that is, you can define a primary key. You can define foreign key. All right, you can define other constraints like unique, not null. You can define these constraints. Correct? So this is true with your any traditional database, may it be MySQL, SQL Server, or Oracle, any traditional database, right? Or for that matter, for Teradata also. Okay, but Hive, it is, as I mentioned, it is not a database. Hey, am I audible now? Yeah, sorry for the network glitch. Yes. Yeah, so I was talking about, relationships. I was talking about constraints. So in your MySQL or in your any traditional databases, you can define constraints. You can define primary key, foreign key, not null, right? Those kind of constraints. But as I mentioned, Hive is not a database. So there is no concept of constraints. With Hive, you cannot define relationships, right? You cannot define that this particular column of my table is primary key, which should refer this particular column as a foreign key. So there is no concept of constraints overall. Reason for this is Hive is not a database, right? It's just converting your SQL to MapReduce. That's it. Okay, so it cannot manage your constraints. It cannot manage your one-to-many, many-to-many kind of relationships. Okay. On the other hand, so if you want to use Hive with, okay, so if you want to use Hive with reporting tools, with your BI tools and all, so Hive has a direct connectivity with your existing tools. So you can connect any of the reporting tools to your Hadoop system using your Hive. Right? So most of the reporting tools available as of today, right, they have connectivity to Hadoop. So if you talk about, say, Cognos, or if you talk about, let's say, Spotfire, or so there are other reporting tools also. If you talk about BI tools like Informatica and all right? Yes, Tableau. So all of these have a direct connectivity to your Hadoop, and this can be achieved. Ultimately, your reporting tools are triggering SQL queries, right? Your Hive supports SQL. That's why these reports can connect to your Hadoop environment using Hive. There is one more competitor to Hive. It's not a part of our syllabus overall. There is one more competitor to Hive, and that framework is called as Impala. Right? That framework is called as Impala. basically Hive is free. Yeah. So Minesh says Spark is also one. Yes, Spark is also there. Okay. But if you are talking in terms of, so Spark, Minesh, Spark is relatively very new and Spark is still not very stable. So in production, only I would say 1 to 5% of people are using Spark in production. Okay, because Spark is not yet production ready. All right. Impala is something which is very robust kind of a query engine. All right. It is similar to Hive. Okay. The only difference is your Hive, it is triggering a MapReduce job. But what your Impala does, it uses your memory, it uses your RAM to process your data. Right, your Hive, it's MapReduce, so it's using a disk to process data. It is using a disk IO. All right. So if you are in your file, you have say 10,000 lines. For every line, your Hive ultimately MapReduce would be doing a disk IO 10,000 times. All right. If you compare that with Impala, what your Impala will do, it will take the entire 10,000 lines in memory and will process your data in the memory itself. So what is the difference? The difference is speed. So if your Hive takes, let's say 5 minutes, your Impala takes 5 to 10 seconds. Right? So it gives you a power of real-time processing over your big data environment. But the thing is, Impala is not free. Okay, it is not an Apache licensed product. It's a product developed by Cloudera. So Cloudera is a company which is selling Hadoop as a package. So Impala is a product of Cloudera. Okay, so these reporting tools which I was talking about, they can connect through Hive also, they can connect through Impala also, right? For my company, for my existing reports which we create, we use Impala, we don't use Hive. Okay, so there's a mix, right? So we have lots of steps in processing the data. Okay, so Bhaskar has a question, how it will get huge data into memory? In big data, we are talking about giga and petabytes of data, right? Okay, so yes, Bhaskar, we are talking about giga and petabytes of data. But if you're using Impala, if you want speed, right, then the first thing you should do is you should invest, right? These memory, these RAMs are very expensive as compared to disk, right? So if you want speed, if you want to use Impala, then you have to invest a lot of money. Right, the clients which I am working with, they are ready to invest. So the overall memory which we have in our system is 1 TB. Right, we have a 1 TB RAM which is used in our cluster. Right, that's why we are able to use Impala. Okay, so Chaitanya has a question, who developed Hive? So Hive, it's a product of Facebook. Right, Facebook uses Hadoop, and basically they wanted a SQL interface over your Hadoop environment. So Hive was developed by Facebook, and later on it was given to Apache and it was made open source. All right. Yeah, so I was talking about my experience. So in my project, we have lots of processing steps. All right. So all our intermediate processing steps, for that we use Hive, right? Because there is a difference in using Hive and Impala. Okay, Impala is not very fault tolerant. If your Impala query fails, the entire query fails. There is no concept of restartability. All right, but Hive, as it is triggering a MapReduce job, if you remember, MapReduce has a concept of fault tolerance, right? If your tasks are failing, it would be automatically read-write 4 times. All right, so your Hive overall, it's very fault tolerant as compared to Impala. There are other limitations to Impala also. The first limitation is it is not, though it is very fast, but still it does not have a concept of restartability. That's one limitation. Second limitation is if my query is failing in Impala, Impala does not throws logs, right? There is very limited logs which are available in Impala. So if my query is failing, it's very difficult for me to identify, to debug what was the actual problem in my query. On the other hand, if you use Hive, ultimately that's a MapReduce, and MapReduce has tons of logs. So you can open the log file, you can check what was the actual issue, and you can debug your code. Okay, you can debug your SQL. So all our intermediate processing, for that we use Hive. Impala is basically used by production users, right? So the business users which we have, they connect. So my reporting tools are basically exposed to my business users, right? So my business users, so the reporting tools, for that we are not using Hive. So for processing we are using Hive. Processed data exposing to the reporting tools, for that we are using Impala, because clients want speed, right? That's why we are using Impala in the final layer. But in the previous intermediate layers, for that processing we use Hive. Right, and Pig also. So like I've worked in many projects, it was only one project in which I had used Pig. So Pig is not very widely used. Okay, the typical use case where you will use Pig is basically for file validations. So we used it for file validations. If you want to check your files, if you want to do some overall high level checks on your files, for that we used Pig. But ultimately the processing, the reason we are not using Pig is our data is structured, right? So why should we go with a different language if everyone knows SQL, right? So we would always prefer SQL over Pig Latin, okay, as the data is structured. So that's why we use Hive. We very rarely use Pig. All right, so Minesh has a question. So Impala is available only on Cloudera, or it can run on Hortonworks? Okay, so Minesh, Cloudera, Impala can run only on Cloudera. Okay, if you're using Hortonworks also has a similar product to Cloudera. Okay, so it's a world of competitions, right? So Cloudera, Hortonworks, Map are all our competitors. So when Cloudera developed Impala, Hortonworks as a competition developed something called as Apache Tez, T-E-Z, Tez. Okay, this. All right. So Tez, it's a product of Hortonworks, right? It's similar to Impala, but not as fast as Impala, right? There is no competition to Impala's speed. Impala is very fast. So we have done a lot of POCs to compare speeds of Hive versus Impala versus Spark. So Impala and Spark are working on the same lines because both are memory processing, but still Impala is way faster than Spark. Okay, so if your query, let's say I have a very complex query, if it takes 10 minutes in Hive, it takes around 4 to 5 minutes in Spark, and it takes around 40 to 60 seconds in Impala. So there's a lots of difference in Impala and Spark also. Right, so Chaitanya has a question, is Hortonworks India based? No, Chaitanya, it is not India based, it's a US based company, right? But actually the owner of Hortonworks is an Indian, right? So that reminds me, so there's a guy called as Arun Murthy. Okay, there's a guy called as Arun Murthy who is from Bhopal, right? He is a major contributor for developing Yarn, right? So Yarn was Arun Murthy's vision, right? Now that guy is CEO of Hortonworks. Yes, Chaitanya. Tez in Hindi means speed, right? Okay. So let's start with the presentation. Right, so we have discussed this. It was started at Facebook because Facebook has lots of data, right? We know how much amount of data Facebook has, right? So it grew from tens of GBs to 1 TB per day, right? And currently it is more than 10 TB per day. So there is huge volumes of data developed at, produced at Facebook, right? Most of the data is unstructured, but where the data is structured, for those kind of data, your Facebook developed Hive, right? Initially, they were using Oracle DB, right? And all their processing was done in Python. So now they shifted the entire Oracle code, entire Python code through MapReduce by using Hadoop, and for that they developed Hive. Okay, so there were lots of challenges which Facebook was facing. There were more than 950 million users, more than 500 TB data per day. Okay, it's 500 TB, sorry. Right, more than 70,000 queries per day, more than 300 million photos per day. So there's huge amount of data, right? Traditional database is not a solution to such huge amount, such huge volume of data, right? The data which we are talking about here, it qualifies as the big data features, right? The big data 4 V's, okay? Volume, variety, veracity, all right? So, and velocity. Okay, so it was a big data environment challenge, which your normal traditional databases cannot handle. So Facebook decided to use Hadoop, right? For processing, they used to use MapReduce. So when this Hive was developed, at that time we just had MapReduce. We didn't had Yarn, right? Yarn, it came up around 2010-11, all right? Hive came up along with Hadoop around 2006-2007. Right? So for processing the data, they wanted to use MapReduce, but they understood that for using MapReduce, they had to code, right? They had to code in Java, they had to code in Python, any programming language, right? So to make it, so give it an abstraction layer, what they did is they developed Hive, right? And they had given a lot of features to Hive. So what features Hive, Facebook developed in Hive is, so they developed in Hive as, so you can create tables in Hive. All right. Again, Hive is not a database, but still you have to use tables. See, ultimately what Hive is giving you, Hive is giving you SQL. All right. What does SQL stands for? It stands for structured query language. Now for using an SQL, you definitely want to have tables, right? You will trigger an SQL on tables. All right. So Hive, it has a concept of tables, but ultimately, if you consider from a Hadoop point of view, a table in Hive is a directory in HDFS, right? A table in Hive table is equivalent to a directory in HDFS. Right? So when I say if you create Hive tables, that does not mean Hive is a database. Ultimately, it's creating directories in your HDFS, and all the files inside these directories, right? The files inside these directories becomes your tables data, right? Becomes your tables data. Okay. So ultimately, if you look at a very high level, if you can imagine the working of Hive, right? Hive is ultimately triggering an SQL on a Hadoop file, right? Ultimately, the SQL which it is triggering, the Hive is triggering, that is ultimately processing your files of your HDFS, right? So that's why there is no concept of a database kind of a thing, but just to manage it properly, just to give it a pure pure feel of SQL kind of a language where we use tables and all. That's why they introduced table concepts in Hive. Okay, so tables. So there are more things around tables. There is something called as partitions. There is something called as buckets. So these are some features for tables which we would be discussing. All right. It has a schema flexibility and evolution. That is, you can define a table. You can change the table's definition anytime. The way you can do it in MySQL, all right? You can alter tables, you can add columns, remove columns, change data types, all these kind of things can be done in Hive. Okay, this is a specific Hive feature. It is easy to plug in MapReduce code in Hive, which is not a pure feature of your MySQL, all right? You can write your MySQL, you can write your MapReduce code, all right? Usually you can write, so let's say I write a MapReduce code in Python. Right, I can easily plug in that Python functionality MapReduce code in Hive. Right, that's an additional feature. So it gives you JDBC and ODBC drivers. That's for connecting through your reporting tools, or let's say through Java if you want to write a JDBC code. Okay, Hive tables can be defined directly on HDFS. Okay, it is extensible. Right, it has various types, formats, functions, scripts. So those are the features, high-level features in Hive. Okay, so Hive, it's a data warehousing package built on top of Hadoop. It is used for data analysis. It is targeted towards users which are comfortable with SQL. Okay, it is similar to SQL, and it is mostly like your MySQL dialect. And Hive's query language, it's called as HQL or HiveQL, which is basically Hive query language. Okay, it is used for managing and querying structured data. So one difference between Pig and Hive: with Pig you can process unstructured and semi-structured data also, but Hive, as it is used as it uses SQL, which typically says structured query language, Hive can be only and only used for structured data. That means if you consider word count kind of a logic, word count can be implemented in Pig but not in Hive, because Hive, it can only process structured data. That's it. Okay, it abstracts complexity of Hadoop. So as a developer, let's say I am a database developer, I have only experience in writing queries in traditional databases. Okay, if you want to use Hadoop, you can directly start working with Hive without knowing how my query is actually going to get processed. Without knowing the internals, that what is map reduce, what is shuffle and sort, what is partitioning, what is uh, custom input formats, output formats, without knowing any of these things, you can still use Hadoop through Hive. So if I am a guy which does not know Hadoop at all, I just know SQL, Hive is the exact proper thing for me. Okay, so Bhaskar has a question: whether we use Hive, Pig, Impala, Spark, all needs HDFS. Is there any alternative to HDFS? Can these processing tools work without HDFS? Yes, Bhaskar, these processing tools can work without HDFS also, but with HDFS, you're getting an additional functionality of your distributed data. You have a functionality of your cluster. You have a functionality of a parallel processing. Okay, so ideally it can work with any file system. It can work with your HDFS. It can work with local file system, right? It can work with your S3, FTP, HSFTP, everything, right? Okay, so it abstracts complexity of Hadoop. Okay, you can use Hadoop. You can use Hadoop without even knowing what is MapReduce if you are using Hive. No need to learn Java and Hadoop APIs. Okay, no need to learn any programming language. It's just SQL will suffice for using Hadoop. So Minish has a question. So we can use Pig for non-structured data or semi-structured data and Hive for structured data. Yes, Minish. Okay, that's the right thing. If you don't want to get into the complexity of Hadoop, okay, complexity of MapReduce, writing a Java code, these two tools will suffice your requirements. Okay, no need to learn Java and Hadoop API, developed by Facebook and contributed to the community. Right? Facebook analyzed several terabytes of data every day using Hive. Right? So Hive, it basically defines SQL-like query language called HQL. H is missing from here. HiveQL. Right? It's a data warehouse infrastructure. It allows programmers to plug in custom mappers and reducers, and it provides tools to enable easy data ETL. Okay. How Hive can be used, where Hive can be used. So the overall baseline is Hive can be used for structured data. So wherever your data is structured, you can use Hive. Right? You can use it for data mining. You can use it for log processing. Right? You can use it for customer-facing business intelligence, like your BI tools, which I was mentioning, like your Informatica and all. They can connect through Hive. It can be used for predictive modeling, hypothesis testing, document indexing. So these are some use cases of Hive. See, if you notice, Hive's use cases is nothing different than your MapReduce use cases. Use cases are same. It is just a language change. That's it. The use cases has not changed. It is just a language change with the limitation that data should be structured. Okay. So why go for Hive when Pig is there? All right. So we know Pig gives you Pig Latin, which is not SQL. It is SQL-like, right? It has functionality like filter. It has functionality like join, group by. Those things are there in Pig, but it is not SQL-like. Sorry, it is not SQL. It is not a typical SQL language, right? It is a different procedural language. It's a data flow language, okay? And it is used by programmers and researchers, okay? With Hive QL, it is declarative SQL language, direct SQL, right? It is used by analysts generating daily reports. So basically used by your reporting tools. Okay, if you compare Hive and Pig, so language, Hive is SQL-like, Pig is Pig Latin. Schemas and types, you have to define schema in Hive because you would be defining table. So if you see Pig, right, defining schema was optional. I may or may not have a schema in my tuples, okay? But if you're using Hive, you have to define a schema because you have to define a table, all right? There's a concept of partitions, which is very specific to SQL. It's there in your Oracle and your MySQL, other databases also. It is basically used for optimization purpose. So if there is anyone who is very good with SQL optimizations, they must be knowing what is partitioning and bucketing. Okay, so that feature is supported by Hive. It is not supported by Pig because Pig is not a data. It is not tables, right? You have a server in Pig. You have a server in Hive and not in Pig. So basically, what is a server? What is the use of a server? So let's say now server is something which can accept queries from multiple users and multiple clients, right? So let's say this is my Hadoop cluster. This is my Hadoop cluster. I can install a Hive server, all right? And this Hive server can connect to your Hadoop cluster. And multiple users can trigger queries to your Hive server, all right? So there are lots of servers available, not lots of, there are 2 servers available in Hive. First is called as a thrift server. Thrift server. And second, which is the latest thing, it is called as Hive server 2. All right. There are some differences between thrift and thrift is basically also called as Hive server or Hive server 1. And the latest Hive server is Hive server 2. When a server should be used? Basically, when you have multiple users triggering multiple queries together, then you should use a server. So Rahul says server means framework. No, it is not a framework. It is like a machine which accepts your queries, multiple queries, and submits onto your Hive. Okay, so it is accepting queries from multiple people. Like it's same like your Oracle or MySQL, right? If you install Oracle, you usually install an Oracle server where you have multiple users triggering your queries, right? Similarly, if you install MySQL, you install a MySQL server, right? If you have experience working on MySQL, you have to install a MySQL server which usually runs on the port 3306. Right, so it's basically multiple users when they want to trigger queries simultaneously on your Hadoop cluster, then you install a server. Again, server, it's an additional feature of Hive. You can work without a server also. Right? It's just when you have if you want multiple users, then you can use server. If you don't want, if it's a single threaded operation, installing a server is not required. Yeah, so Manish has a question. Can single service can send multiple SQL to the same file system? Yes, Manish. That's the use of a server. That's why if you want to accept multiple queries and send it to a file system, that's why you install a server. Okay. Right. You can write custom user-defined functions in both, right? In Hive also, in Pig also. So we know what is UDF, right? So the functions which are not given by your tools, which is not given by your frameworks, if you want to plug in your own processing logic, you can create a user-defined function. Again, Hive, as compared to Pig, both are written in Java, right? The basic language in which Hive is written, that is also Java. Okay, so if you want to write a UDF, you have to use Java. Okay, custom deserializer, serializer, yes, you have, it's there in both. Direct access, HDFS direct access, yes, in both. Joining, ordering, sorting, it's available in both, right? There is a shell available in both. You have a Hive shell and you have Grunt in Pig, right? Streaming, both have, okay, Hive has a web interface whereas Pig does not. Web interface comes only if you have a Hive server installed. If you don't have a Hive server, there is no web interface, right? And it has a connectivity with JDBC, ODBC, whereas Pig does not have it. Okay, so this is an overall Hive architecture. So I will just use a spotlight. Okay, so this box, the first box you can see, that's Hive. Right. Chaitanya says web interface uses JDBC. No, web interface is basically for managing your all your Hive metadata and all. It is actually not used for querying. Okay, it's an administrative kind of an interface, right? Not a developer interface. Okay, so it does not uses. It is not querying your data. It is managing your server, like how many users it should accept, what is the Java heap size of your Hive server. Those administrative kind of things you can configure in using web interface. All right. So this first box which you can see, this is Hive. So these are the things available with Hive. It gives you a thrift application that's nothing but a Hive server. It gives you a JDBC and a ODBC application. So you can connect to Hive using a JDBC and ODBC. All right. It has an internal JDBC driver and ODBC driver, which connects to your server. And this HWI is basically your Hive warehouse. And it also gives you a command line interface, right? That's your shell, Hive shell. Okay. There is one more component to Hive that's called as the meta store. All right. And there is a driver which is basically responsible for converting SQL to MapReduce. So it compiles your code, optimizes it, and executes it. Right. I will discuss what is meta store. All right. And ultimately, Hive is referring to your Hadoop. That's your HDFS and MapReduce. And these are some tools which uses Hive. So there's a tool called as Karmasphere. You have you have Qbol, and there are some other reporting tools which can use Hive. Let me tell you the concept of Metastore. This is very important. Metastore is very important piece in your Hive. So basically what happens in Hive is, so as I mentioned, if I create a table in Hive, right? If I create a table, what do I specify? I specify the schema. When I say schema, basically I specify the column names and the column data types. So inside a table, I define my schema. All right. Now, if you consider from the point of view of Hadoop, let's say this is your Hadoop. Right? A table in Hive is nothing but a directory in your HDFS. All right. But the schema, right? The schema is something extra information about your table, right? It is extra information which is defining your table, which is describing your table. So the schema is very small, right? So this schema is not stored to HDFS. All right, the schema of your Hive, it is not stored to HDFS. Listen to this carefully. It is stored to a database. When I say database, it is your traditional RDBMS. This means if you want to use Hive, you should have a database installed. So database can be anything. It can be MySQL, it can be Oracle, it can be Teradata, anything. Right? Now, why Hive uses this database? Okay, it is just to store the metadata. Right? It is not actually storing your data. Okay, the table data where your Hive is referring from, table data is referred from your HDFS. But the extra information about your table, all right? For example, HDFS, which location of your HDFS? Schema, how many number of columns are there, right? Is my table partitioned or not? What are the data types of my columns, right? This additional information about your table, it is stored into an actual database, and this database, it's called as metastore. So if you want to use Hive, you have to install a real database also. Yeah, so Minesh says it creates its own table to store schema data. Yes, it is similar to Informatica. Right? So basically, for using Hive, you're using a traditional database also and Hadoop also. Actual data in Hadoop, metadata in database. All right? So that is called as metastore. If your metastore database is not working, let's say metastore data is not working, you will never be able to access Hive, because whenever you trigger a query, whenever you trigger an SQL to Hive, Hive will first go to your metadata to fetch the table name. So in my query, I would specify my table name also, right? That table's data at what HDFS location it is stored, that information is managed in your metastore. So for every query, Hive connects to your metastore first, gets the metadata, it checks your query, compiles it, triggers it on your HDFS using your MapReduce and ultimately your yarn. So this is an overall flow. So for Hive, you have to use a database. All right, so Chaitanya says that database should support Linux. No, Chaitanya, this database can be on anywhere. It can be on a Windows machine, it can be on a Linux machine. Your Hive should just have a remote connection to that database. That's it. Just a remote connection is required. Environment is not important. It can be on anywhere. So Minit has a question. So log is created in both places, HDFS log and Hive log. Yes, exactly. So Hive log is overall maintained, whenever you will be using Hive, a file is created called as hive.log. That will contain information about your processing data also and your metadata also. HDFS logs will contain only processing data. That's your MapReduce logs. All right. Yeah, Manish, no issues. You can ask as many questions as you want. Okay, so that is the metastore. So we have different types of metastore. One is called as a local metastore. One it is called as a standalone metastore. One is called as a remote metastore. So we'll discuss these things about metastore. Yeah, so she says any RDBMS database is supported. MongoDB, MySQL. MongoDB is not RDBMS, Shri. MongoDB is a NoSQL database. So MongoDB is not supported. MySQL, Oracle, Teradata, SQL Server, right? These kinds are supported. So Bhaskar says, so once the file is stored in HDFS, we need to explicitly store some of data in Hive metastore. No, Bhaskar, you have to just use your Hive queries. So let's say I want to create a table. So I would use a Hive query to create a table. Create table name. I will define a schema. Hive will implicitly store the metadata to your metastore and your data to your HDFS. You are not accessing your metastore directly. You should not connect to your metastore directly. Your Hive itself will take care of that. Okay, so you're saying file information. So file information, again, everything for developers, for us, it's through a query language, through a query. All right, and that query is a Hive query. So you're not connecting to your database Metastore directly. You are just using your Hive interface, which will internally take care of storing anything and everything in your Metastore. Okay, so what Hive has, it has a compiler, driver, shell, Metastore, and execution engine. Right. So these are the Metastore, the types of Metastore I was talking about. So there is one Metastore called as embedded Metastore. Now what is embedded Metastore? So let's say I want to use Hive. Now it's very difficult, right? First install Hive, then install a database, then attain a connectivity between a Hive and that database. It's very, there's lots of work to do. Okay, if you just want to get started using Hive, what you can do is directly install Hive. All right, don't install any database and all. All right, Hive itself comes with a internal database, inbuilt database. All right, that database which your Hive uses internally without any external installation, that database is called as Derby. Now what is Derby? Derby is a database just like your MySQL and your traditional database. The difference is it is very lightweight and it is in memory. For, let's say I want to use MySQL, you have to install MySQL. Right? For Derby, you are not installing anything. Okay, you can just install Hive and start querying. All right, Hive will automatically store the metadata inside Derby, which is a type of database which Hive uses automatically, internally, default database used by Hive. Yeah, so Rahul says like SQLite, exactly, it's like SQLite. It's a very lightweight database which is in memory. Okay, so it is good to start with Derby if you want to use Hive. Okay, no additional things to install. But there is some limitations of using Derby. Okay, see your Hive can have multiple users together. Okay, but Derby, it does not allows multiple users. So if you're using Derby, you can have only one query at a time. You cannot trigger multiple queries. This is a limitation of Derby, not Hive. Hive can accept multiple queries together. Okay, but Derby, see, every query you trigger on Hive will connect to your Metastore. Derby can allow only one user at a time. Okay, which makes your application single-threaded. Right. So if you're using a default Hive Derby database, you cannot trigger multiple queries at a time. Okay, you cannot have multiple users using Hive at a time. That's a limitation of using embedded Metastore. That's your Derby default Metastore. But if you want to just practice Hive queries by your own, you will be triggering only one query at a time, right? It's good to start with Derby. The other type of configurations of Metastore is there is a local Metastore. Now, what is a local Metastore? You install MySQL or any database on the same machine where Hive is installed. Okay, that's called as local Metastore. And what is a remote Metastore? Your Hive can be installed on one machine, which can connect to a database which is installed anywhere, any other machine, remote connection. Right? See, if I want to write, if just consider an example of JDBC code. Let's say I am using Python or Java to connect to a database. What I usually do, I specify the host name and the port of my database, right? If I'm using JDBC Java, I specify the IP address of my MySQL server. Okay. If I use Python, I use a Python package in which I specify the MySQL IP of my installation, a remote IP. Okay. Same thing your Hive can do. Right? Your Hive can connect to a database which is installed locally, or it can connect to a remote database. Now this remote database can be on any machine. It can be on Windows, Linux, Mac, anything. It is just a connectivity should be there. Okay. Now by using MySQL or any traditional database other than Derby, your limitation of having a single user has gone. Okay. MySQL can accept multiple queries together. All right. That's why your Hive can accept multiple queries together. Okay, so if you want to have multiple users using Hive, you should definitely use MySQL. And configuring how to use this MySQL, it's not a part of our syllabus, but still, it's very simple to configure Hive to use MySQL. So if you install Hive, it is very similar to your Hadoop installation. Okay, so Minesh has a question. If you keep changing your Hadoop clusters, which stores location in Hive database, does it take lots of disk space? No, see, Minesh, so in Metastore, only your metadata is stored, right? So metadata is not very huge. Okay, it does not take a lot of space. Your actual data will take a lot of space. That's why we are going with Hadoop, right? With Hadoop, huge files is nothing for Hadoop. It is meant for huge files. Okay. That was about your Metastore. Achha, yeah, so additional information I was talking about. So if you install Hive, so Hive installation is not a part of a syllabus, but installation is very similar to your Hadoop installation. So if you download Hive from Apache's website, if you unzip it, you will find similar folders like your Hadoop folders. You will be having a conf directory. You will be having a bin directory, right? A lib directory. So it's just like your Hadoop installation. Like if you're configuring Hadoop, you have some files like your Hive site. You have your files like your core site.xml, hdfs site.xml, yarn site.xml. Similarly, for Hive, you have a file called as hive site.xml. And in that file, you specify your properties, which is the same way you specify it for Hadoop. Same XML file, property, you give a name and a value, and there is a fixed property for using a remote database, right? So you can define which database to use. You have to define the driver. So for MySQL, it will be com.mysql.jdbc.driver, right? You have to define the username of your Metastore, the password, and all those things. For such things, you have predefined properties, and where you will specify this in your Hive site.xml. So installing Hive is simple, all right? It's not a lot of things to do. So there are some limitations for Hive. Okay, so what is the first limitation? It is not designed for transactional processing. So as I mentioned, Hive cannot be used for real-time processing. When I say transactions, it's a real-time data. Okay, so Hive cannot be used for processing real-time data. The reason for this is Hive, it's ultimately a MapReduce. Okay, MapReduce cannot do real-time processing. It can only do batch processing, sequential data access, where full table scans are always there. That's why you cannot use it for transaction processing. Okay, it does not offer real-time queries and row-level updates. So one thing we know with Hadoop, right? You cannot update data in HDFS, correct? HDFS is not meant for updates, right? So this is the reason if you're using Hive, still you cannot update data because ultimately data is there in HDFS. You cannot update your data. See, if I create a table, so help me out with a query. Let's say I create a table in, let's say, MySQL. I want to insert a row. What is the query for insertion? So yeah, so Chaitanya and Rahul says insert into table name and you say values. Okay, so what this query will do? This query will insert one row of data. If I want to insert 10 rows, I would trigger this query 10 times. Okay. When I insert data, basically I'm updating a file, right? Hadoop is basically storing your Hive is basically storing data in Hadoop as files. Okay. Inserting a single row is basically nothing but updating a single file. This is the reason this query is not supported in Hive. Right? Insert into table values where it inserts a single row. Such queries, right, where you're doing updates, such queries are not at all supported with Hive. If you want to insert data to Hive, the only option is bulk load. You have to insert the entire file together. Okay, you have to do bulk loads in Hive. You cannot insert single row. You have to insert the entire file together. So that's one limitation of Hive. Okay, that's not a limitation of Hive. Basically, it's a limitation of your overall Hadoop only. Okay, so you cannot insert single rows. You cannot update anything. So there is no query like update table, set column name equal to a value. You cannot update anything in Hive. Once your data is there, it's there. You cannot update. You can transform your data. From one table, I can query and transform my data and store it to other table, right? But one table itself, I cannot update. Okay. Latency for Hive queries is generally very high. Again, the same reason, it's MapReduce. MapReduce is not fast. It is sequential. Okay. It provides acceptable latency for interactive data browsing. Okay. So if you want, so Hive basically gives you a Hive shell also, a command line interface where you can query, and there itself you will get the output. But that is also time consuming. It is not very fast. Ultimately, it's MapReduce. So until my MapReduce finishes, you won't get your output, though you are using a Hive command line. Right? Abilities of Hive query language. So it has the ability to filter rows using a where clause. It is same. Abilities are same like your any other database. Okay, you can use a where clause. It has ability to do equi-joins between two tables. Ability to store the results of a query in HDFS. It has ability to manage tables and partitions. Right? You can create table, drop table, alter table. Okay, so basically you can update the metadata because metadata where it is stored inside a database. Database supports updates, but data does not support updates, right? Because data is there in HDFS. Okay, so you can update the metadata. Basically, you can alter. You can use the alter query. Okay, where you can add columns, delete columns, change the data types. Basically, anything with your metadata. Okay, but the actual data cannot be changed. The reason is HDFS. Right. So Rahul says the result of a query is not stored automatically. So Rahul, depends what type of query you are using. So if you are just using a select query, if you are logged in into a command line, if you just say select something, it will display the output. It will not store. If you want to store it in HDFS, you have to use a query like insert into table and then use a select query. Right? So that table in which you would be inserting, that table would be in HDFS. So if you're just triggering select queries, it is not stored to HDFS. It is just displayed. Okay, similar to your dump operator in your pig. If you want to store the output, you can use insert into a table, and you can use a select query. Right. So Rahul says part file will not be created. See, ultimately it's a MapReduce job, so part file would be created, but it would be created in a Hive temporary location. Okay, which we don't usually see. Okay, because we just want to see the output. If you are writing a select query, so you will see the output there and there itself. It is just stored in a Hive temp location. Okay, it has ability to store results of a query into another table. That's why I was talking about insert into table and a select query. So that will insert one table's data to into another table. You can insert to a table, you can insert to a directory. Both the things are allowed. If you don't use insert into, right, you can, if you just use select, it won't store anything, it will just display. Okay, difference between your Hive and traditional database. So the same thing, schema on read versus schema on write. So this I told you yesterday. We would be reiterating through this again. Okay, so what was schema on read and what is schema on write? So tell me what Hive would be, schema on read or schema on write? Which approach Hive will take? Schema on read or schema on write? Okay, so Rahul says right, Bhaskar says right, Sanip says right, and Kishore Chaitanya Abhilash says read. Okay, so let me explain you the difference. So let's say I define a table in your MySQL or Oracle. I say employee ID, which is an integer. I say department ID, which is an, or I say department name, which is a string. All right. If I insert this data, will this be accepted? Exactly. Yes. If I insert this data, will this be accepted? Exactly. So everyone, Sanip says yes. No, Sanip. Everyone says no. Sanip says yes. So Sanip, it won't be accepted. I'm talking about your Oracle or MySQL. Okay. What your Oracle will say, your Oracle will throw an SQL exception. The reason is, in the first column, it was accepting an integer, but I passed a string. That's why it will not accept it. It will throw an SQL exception. Data type mismatch. Okay. This is what is schema on write. While writing it, it is verifying your data with your schema. This is your schema on write approach, right? Now let's say this is not a, this is a Hive table, right? This is not a MySQL table, okay? Your Hive will accept. Hive will not throw any error for writing this data, for inserting this data. Hive will simply accept it. The reason is, my big data environment, my data can be very huge. With huge data, there is a problem of quality. Some of my rows can be of bad quality. All right. If you're, yeah, so Chaitanya says because it converts to bytes. No, Chaitanya, not exactly. Basically, the reason is it does not checks. When it is inserting data, it does not verifies your data with your schema. There is no check mechanism. This is same with your pig also. Overall, in any big data environment, all the tools are always schema on read. May it be Pig, may it be Hive, may it be Spark, or may it be any other tool which is still not developed. It will be always schema on read. Because if you're, because we are dealing with huge files, right? Some of the, when I'm dealing with huge data, there can be a problem of quality. Some of my rows of my data can be of bad quality. If your tool starts to throw any errors, how difficult it is for me to check on which row it is throwing an error, and how difficult it is to go and correct that row, because we are dealing with huge data. We are dealing with terabytes and gigabytes of data. Okay, so we cannot go open a file, change that row. It's not possible. With Hadoop also that is not possible, because Hadoop does not allow updates. I cannot update a single row. This is the reason your such big data environment tools will never throw any error. It will accept data. So Minay says, how do you check initial data? Let's say 10 rows in Hive. So Minesh, your Hive has a query like limit. So I can say select star from table limit, and I can give a number similar to Pig. All right. So if you insert this data to Hive, it will accept the data. When you will start querying this data, if you say select star from this table, okay, this is the time when this data mismatch, when the schema mismatch will be observed. So what your Hive will do, Hive again will not give an error, right? Again the same thing. If your Hive gives an error in a select query, again the same problem. How will I correct the data? So what your Hive will do, Hive will return this output. It will return Hive will return this output. So if there is a mismatch, Hive will simply show you null. Okay, now very important. Hive is just showing you null. This does not mean your file contains null. Your file is this. Your file will contain 2, TWO. Okay. Hive is not able to verify that with your existing schema. That's why Hive, just for the sake of showing it, it will show you null. But if you actually go to your file in your HDFS, open the file and see, it would be not null. Okay. So this thing is very important, right? Okay, so schema on read versus schema on write. Hive does not verify the data when it is loaded, but rather when a query is issued. Schema on read makes for a very fast load since the data does not have to be read, parsed, and serialized to disk in the database internal format. Right? The load operation is just a file move operation, copy or move operation. So basically, when you're loading, when you're doing bulk load, if you compare the speed of your Hive versus MySQL, writing it in traditional database would be very slow. Because let's say I'm doing a bulk load of say 10,000 lines, 10,000 rows. MySQL will internally parse each and every row, compare with schema, and then store it. On the other hand, Hive is not verifying your schema. When you say load data to a Hive table, it will simply copy that file from a normal location to your Hive tables location. That's it. It is just a file copy operation. Okay, so loading a file in Hive, it's very fast. Okay, to be specific, it is not a file copy operation, it's a file move operation. Tell me one thing, I'm doing a copy in Hadoop, compare with I'm doing a move in Hadoop. Which would be faster and why? So Chaitanya says move would be faster. Sanip says, Minesh says copy. Okay. All right. So Rahul gave an exact answer. Okay. Rahul says move would be faster because it is only changing the metadata. It is only changing the path. Right. See, when I'm copying, what I'm doing, I'm creating duplicate blocks. Let's say I'm copying a 1 GB file from location A to location B. I'm creating 8 different blocks for my location B also. All right. That's basically I'm duplicating my data. Right, creating 8 more blocks for existing 8 blocks, it has to deal with replication, right, and all those other havoc, right? For move, what I'm doing, I'm not even touching my blocks. I'm just updating my metadata. When I say metadata, just the path of my file I'm updating. And where this path of your file stored? Who is storing your path of your file? Who is storing your metadata? Yeah. So everyone says master, name node, okay? And it is stored in your name node memory. So move operation, it's actually a memory operation. Memory operations are very fast, okay? So Bhaskar has a question, what it means by loading a file in Hive. File data is in HDFS, right? You mean the result of Hive query? No, Bhaskar. So when I create a table in Hive, initially the table would be empty, correct? If I want to insert data, so Hive has a query called as load data, and you can pass a path to it. Okay, so let's say I'll just draw it out. I have a folder called as, let's say, user X and user Y. Right, this user Y contains my 10 GB file, which is my actual table data. Right, if I create a Hive table, right, Hive table, let's say I created on this location. Right, initially, when you will select data from this Hive table, you will get 0 rows because this folder contains no files. Right, so there are 2 ways to load data. Either you can copy or move this file from here to here. That is one way. That how will you do it? Using your normal Hadoop fs-cp or -mv, using your Hadoop commands. If you want to do it through a query, Hive comes with a query, load data in path, and you can specify a path, and you can specify after that into table, and you can specify a table name. So I can say this path, I can give this file's path. Okay, so this is what I meant by loading data to Hive. So what Hive will do, when it sees this query, when it executes this query, it will move this file, which I've given in this location, from here to here. That is what I meant by load data. So initially when you create a Hive table, that is empty. Right? I hope that answers your question, Bhaskar. Okay, so Abhilash says, so Hive will have its own file system. No, Abhilash, Hive will have its own folder, but the file system would be same. File system is HDFS. It will just have a folder in HDFS. Right? It's not a separate file system. Ultimately, the file system is Hadoop, HDFS file system. Just Hive will have its own folders. Yeah, so Chaitanya says, can we copy the file with different names? Yes, Chaitanya, you can. Right? Hive does not check for the file names. It just checks that folder has files or not. File name doesn't matter. Right? And the difference, other differences, there is no updates, no transactions, no indexes. Right? Indexes, it is introduced in Hive in the latest versions. But yeah, I mean, it is not meant for real-time processing. That's why it's no indexes. Okay, now let's look at the data types of Hive. Okay, so it's integer, and integer you have multiple types. You have int, big int, small int, and tiny int. Okay, so it depends on what is your bytes of your data. You can define any of these. Right? For strings data types, you have string. So there is no varchar. Okay, like you have an Oracle, right? Varchar, varchar2. It's nothing varchar in Hive. You have string. Okay, and there is no limit to this string. Like if in varchar you can define the limit, right? You can define how many characters would be there inside my string if you use a varchar or something. But if you are using data type as string in Hive, you cannot define what should be the length of that string. Okay, ideally Hive's string length can be unlimited. Right? For floating numbers you have float and double. For Boolean you have Boolean. Right? A few new data types have been added to this Hive system in the latest versions. So we have a new data type called as decimal, okay, which was not available in the previous versions. Okay, so with decimals, you can define the precision values also. Okay, like how many numbers you want after the decimal point. That precision you can specify if you are using a decimal data type. So these are the primitive data types. Hive also supports complex data types. It supports arrays, maps, and structures. Okay, so it supports an array. That's nothing like a type of a list. It supports maps, that is a key value tuple, and it supports structures. Structures is very similar to your JSON kind of a file. Okay, but if you would be using Hive, complex data types are not much used. Okay, complex data types are not much used. Most of the used data types is your primitive data types, but still it is available in Hive. Like if you will consider pig, in pig, if you don't know the complex data types of pig, you will never be able to use pig. You should know what is a tuple. You should know what is a bag. Right? In Hive, that is not the case. Right? If the data types are there, it may be used, it may not be used. It just depends on your use case. So Rahul has a question. JSON cannot process in Hive, right? Rahul, JSON can be processed. Okay, so basically Hive has a inbuilt function which can parse JSONs. So what you can do is, if you have a JSON, you can load it to a Hive table with only a single column. Okay, so let's say I have one huge JSON file. Okay, what I can do is I can create a Hive table with a single column. Let's say column 1, and I can define that as string. I can insert this entire row as a single, this entire record as a single row in my Hive table. On this column, this will contain a single row which would be your entire JSON file. And on this column 1, you can use your JSON methods, JSON inbuilt functions, which your Hive gives you by default, to parse your keys and values. So processing a JSON file is possible. Okay, if your Hive is not doing the exact way as you wanted, you can write your own UDF for processing JSON files. The only limitation of such use cases is your entire file, your entire JSON record should be in a single line. Hive will not allow multiple lines JSON record. This will not be allowed. Your entire JSON record should be in a single line. There should not be any \n character in a single record. All right, so if I'm discussing this, this brings me to another limitation of Hive. Again, it's not there in the syllabus or in the slide, but it's just through personal experience. When you define a table in Hive, okay, let's say I have 10 rows in my file. 7, 8, 9, 10. I have 10 rows. This is my, let's say, file 1.txt. Right? I create a table, Hive table, which has a single column, column 1, whose data type is, let's say, string. When I load this file to my Hive table, my Hive will have 10 rows automatically. Okay, but if your data contains \n, that's a new line character. Okay, if you, let's say, out of these 10 records, one of the record contains \n. When you load this data to a Hive table, Hive will show you 11 records. Hive cannot handle \n characters within your data. Hive will only allow \n, that's a new line character, only at the end of the line. So when your Hive sees that it is getting a \n, it will consider that your record is finished, and it will, the remaining part of your data would go to the second row. For example, if this is my one row, I have a \n here. Hive will consider this to be one row and this to be row 2, but ideally it is a single row. Such cases cannot be handled in Hive, right? You cannot escape \n characters in Hive with any version. Even in the latest versions of Hive, this is not supported. So Rahul says we can write customized load to escape \n. No, Rahul, you cannot do this also. All right, you cannot do anything with \n. Okay, so Rahul has a question. So file 1 can be just one line with 10 \n. Yes, that is also possible, Abhilash. But Abhilash, if you consider that one line to be a single record, Hive will ultimately convert it to 10 records. Where ideally it should be one, Hive will show you 10. Okay. Okay, so this brings me to another limitation of Hive. So when you load data to Hive, okay, when you load data to Hive, ultimately it's loading your text data. All right, and your text data should be structured. When I say structured, basically it should be delimited text, either a comma delimited file or any character delimited file. It can be a tab delimited, dollar delimited, any character delimited. When you create a table, you have to specify the delimiter. Okay, when I create a table, let's say this is my file, column 1, comma, column 2, comma, column 3, comma, column 4. If I create a table in Hive, I have to specify that the delimiter, I have to specify that the delimiter is a comma. Only then Hive would be able to convert this for this is basically single line, right? In my file, it is a single line. If you specify a delimiter, only then Hive would able to know that this is my column 1, this is my column 2, this is my column 3, this is my column 4. So you have to specify a delimiter, same like pig. Same like pig. Okay, one more limitation here. Let's say our column 1, it contains this column 1 data. This itself contains a comma or the delimiter. For example, let's say this is your data. I have employee ID, I have employee address, and I have, let's say, email ID. Okay, it's better to use a notepad. I have employee ID, address, and mail ID. If this is my data, employee ID 1, address is, let's say, and mail ID is, let's say, right? So what you're seeing here is, if I insert this data to my Hive, what Hive will do, I will specify my delimiter as comma. I would specify I would be having 3 columns. So in your column 1, Hive will put the data employee ID. In your column 2, here is a catch. Hive will put your data Mumbai. In your column 3, Hive will put the data which is ideally wrong, correct? Because these two things is a part of my single column. But if your data itself contains the delimiter, my data itself contains a comma, which is my actual file delimiter, this case is Hive you cannot escape this comma. So what will happen, this email ID, where it should be there in your column 3, you will have this Maharashtra there, and this email ID won't be visible in your Hive. It is there in your file. Okay, data is not gone. Data is there in your file, but Hive table will not show you that email ID unless your table had one more column. Getting this? To handle such cases, right? This can be handled. Okay, \n cannot be handled, but such cases can be handled. Okay, you can convert this file to a CSV file. When I say CSV, I mean to say a quoted CSV. With this quoted CSV, now this becomes a single column, though my delimiter is there inside my data field. Okay, so your Hive something has called as a CSV SIRDAY. Now what is a SIRDAY? Basically it stands for serialization, deserialization. Okay, it's nothing but a Java class which handles such scenarios. Any doubts in this? Okay, so Rahul has a question. During load, we have to give this command. Yes, Rahul. No, so it's not during load. It's when you define a table. When I say define a table, when you create a table, you have to specify the delimiter. Okay, if you know that a table would use a CSV SIRDAY, you have to define that when you create a table. Okay, it's not during the load time, it's during the create time. Abhila has a question, so file one. Okay. Sorry, Minesh has a question. Output table means output file, right? Yes, yes, Minesh. I'm talking about files. When I say table, it's basically when I'm talking about this data, it's basically files inside a folder table. Okay, I'll give you one more scenario. See, this is very useful, not there in the syllabus, but let's say I have my data in this way. I have a column 1, comma, column 2. I have dollar comma 3, column 3. I have, let's say, star column 4 and comma column 5. So basically what do you see here? I have 5 columns, but my delimiter is not uniform. Between first 2, my delimiter is comma. Between second and third, my delimiter is a dollar. Between third and fourth, my delimiter is a asterisk. And between last, my delimiter is a comma again. So basically, this multiple delimiters, such files cannot be loaded to Hive by default. Okay, such files. So basically, when you create a table, when you define a delimiter, you can only define one delimiter. You cannot define multiple delimiters. Okay, see, this will usually, you will face these issues when you will be actually working on Hive in a live project or something. Right? But to know it beforehand, it's very helpful. Okay, so such type of data which has multiple types of delimiters, it cannot be loaded to Hive directly. In such cases also, you have a survey. So there are lots of surveys available in Hive. One we saw a CSV survey. Such kinds can be loaded through a survey which is called as a regex survey. You can define a regular expression for loading such type of data. And this regex survey is also inbuilt. So the surveys are nothing but Java classes, right? It's inbuilt and you can just use them directly. And where do you specify all the surveys? It's basically when you create a table. Where do you specify my file is a delimited by comma? When you create a table. Everything is when you create a table. Okay. Any doubts? Like, are you following this or it's going a bounce kind of a thing? Great. All right. Okay, so Hive supports multi namespaces, similar like your MySQL. Okay, you can create a database in MySQL, right? You have commands like create database and you specify a database name. Then you have commands like use database. You have commands like drop database. Right? This thing is possible in MySQL or Oracle. Everyone is familiar with this. Is there anyone who does not know what is this namespace? What is this database? All right. So this is the thing which Hive also supports. Hive also has multiple namespace option. Okay. So you can create a database in Hive also. Okay. See what Hive will do. So let's say I create a table in Hive. Okay. So tables we haven't yet covered. What types of tables are there? Right. So I'll discuss this when table thing comes. Okay, just consider for now, when you create a database, it creates a folder in your Hive HDF, in your Hadoop HDFS. So let's say I create a database. Let's say I create a database, let's say test. What your Hive will do, it will create a folder test.db. In your this is a folder, test.db, it's a folder in your HDFS. If I create a table inside this test database, let's say I create a table, let's say dummy 1, it will create a folder inside this dummy1 folder. So it's basically nested directories. So this is what what I mean by create database. Now, what is the use of creating multiple namespaces? Any logic, any use case? Why you should use multiple databases? Or tell me, can I have two tables with the same name in Hive or Oracle or MySQL, any database? Can I create two tables with the same name? And so everyone says no. It simply gives you an exception. Table already exists. Okay, but if I want a same name, I can create it in a separate database. It is just basically you can consider this to be a Java package kind of a thing to manage your data. Okay, yeah. So Minesh says unless different schema. Okay, so this create database is nothing but a different schema, right? So let's say this database is usually used a lot. Okay, so in our case also, what we usually do, we get, so in our case, what is our case? We get raw files from the clients, from the data vendors, not the clients, from the data vendors. What we do, we process that file, and that processing, there are lots of steps in processing. And ultimately, the processed data, we expose it to the clients. Okay, now my data is of same type. Okay, what I'm getting, what I'm processing, what I'm exposing to the client, it is of the same category, you can say. So it's always better for me to use same table names. So how we handle this situation, we, all the raw files which we have, we create a database called as landing. Okay, for the entire data set which we have, let's say I have 10 tables. So I create 10 tables inside landing. I create 10 tables inside landing. The same tables which I have inside landing with the same names, when I process it, I use a different database, a different schema, right? We call that as staging, or we actually call that as working. So what we do, let's say I have a table T1, T2, T3, T4, and so on. The same table I have here, T1, T2, T3, and T4, and so on. Table names are same, but just the database is different. Ultimately, these 4 tables should be exposed to my client. So I create one more database called as production, which will have these tables. So this is a typical use case where you should use multiple databases. Can anyone tell me how will I join this T1 table with this T2 table? T1 table from my landing with T2 table of my working. Yes, exactly. So I can fully qualify my table. How to fully qualify a table? It's basically database name dot table name. So I can say landing dot T2 equal to working dot T1. So I can fully qualify a table using database name dot table name. Yeah. So the same things which are there in your normal database also, same thing is supported in your Hive. Okay. Data. Now partitions. Okay, partitions, buckets. Let's discuss after we discuss what are tables. Right. I will discuss this after tables. So this is how you create database and table. Okay. All right, let's have a break. Right. So everyone says let's have a break. Let's have a 5-minute break. Okay, and then we will discuss about databases and tables and partitions buckets in Hive. I'll just set up a timer. If you have any questions, you can ask me now. Right? If you have any questions, you can just put it down. Yes. Yes, Rahul, you can. So Rahul says, can I ask you real scenario related to my work? Yes, Rahul, you can. So Chaitanya, to answer your question, so Chaitanya had a question, which tool is used for real-time processing in Hadoop? So real-time processing, now we have Spark, okay, which gives you a near real-time kind of a processing tool. Then we have Impala, right? HBase can be considered as a real-time processing kind of a thing, okay? Okay, so let me just read Rahul's question. All right. So Rahul, you say, so Rahul has a question that we have sensor data which return the JSON data, and JSON property contains another service URL and so on. I'm traversing all and storing into SQLite database every 15 minutes. Then we have to use this data for analysis. Example, item chiller JSON1, chiller property label managed mng date or something. Row data, up down timestamp temperature. How can we use this in Hadoop? So Rahul, actually, we also have one use case in this. Okay, we also process sensor data, but the sensor data which we get is it's not JSON, but yeah, it is some unstructured kind of a thing. So what we do is we use Spark for this. Okay, so there is a tool in Apache for big data environment called as Kafka. It's not a part of the syllabus. It's a very advanced and the latest kind of a tool. What Kafka does is it streams your data from source to wherever you want. Okay, so we use Kafka. What Kafka does, it reads the sensor data and streams it. And where it streams, for that we are using Spark. It streams to a Spark, and there's a framework in Spark called as Spark Streaming. What Spark Streaming does, it can process real-time streaming data. All right. So what happens? Kafka reads the data from the sensors. It streams it to your Spark Streaming. Spark Streaming processes your stream data, which is on the fly, real time. And the processed data, we put it to a HDFS file. Ultimately, that's a Impala table on which we create reports. Okay, so you can actually explore things like getting streaming data. So there are two tools available for this. One is Flume, one is Kafka. So you can explore on these two options. And for real-time processing, you can explore for your Spark streaming option. Yeah, both are open source. Okay, Kafka is also open source. All are Apache. Spark, Kafka, Flume, everything is open source. So Minesh says, is Tez as good as Impala? No, it is not. There is no challenge to Impala. Impala is extremely fast. So we have used lots of tools, but to attain the same speed as Impala gives, we still are not able to find such tool. Impala is very, very nicely built. Yeah, so Chaitanya says, is Impala also query language? Yes, Chaitanya, it's same like Hive. Okay, the same query which you're running on Hive, same thing you can run on Impala also. Okay, the only difference is the execution time. Hive will take 5 minutes, Impala will take 10 seconds, 5 to 10 seconds. It's very fast. The best thing with Impala is Impala shares your Hive metastore. Okay, this means if I create a table in Hive, Impala will automatically recognize that table. Okay, because the metastore is shared. I create a table in Hive, it is automatically available in Impala. I create a table in Impala, it's automatically available in Hive. Okay, so there's no need of creating additional tables, no need of managing metadata and all. Okay, so if your cluster have already Hive installed, you can simply put Impala and start querying data without worrying about creating databases, creating tables, loading data, nothing. Okay, but when I say Hive, Impala is very fast, but at the cost of RAM. Okay, it requires a lot of memory. So I'll tell you, we have a 1 TB memory overall. Okay, we use around 6 node cluster, it's a 5 node cluster. Every node has 256 GB RAM. It's a very heavy machine. Every node has 256 GB RAM and it is having around 128 cores of processors. It's a very expensive machine. It's a AWS machine. It's not a on-premise. It's a on-cloud machine. The charge is around 1.5 or $2 per hour. Right? So we use 5 machines. Overall, total memory is 1 TB. Out of that 1 TB, we have given 300 GB to Yarn and the remaining 700 GB to Impala. Because Impala requires way lot of memory. Okay, Yarn can still work with less memory. Impala cannot. Impala requires a huge memory. So almost 70% we are dedicating it to Impala. Yeah, so Minesh says still AWS is very cheap. Yes, Minesh, it is very cheap. So $2 per hour, if I say 5 machines, it's almost $10 per hour. Okay, so it's okay. I mean, if you use such huge machines on your premise, so the purchase cost would be very huge. The maintenance cost would be very huge. That is all eliminated. Okay, and the best part with AWS is if you have all your machines on AWS, AWS has a very good network connectivity. Right? If you want to transfer some data between your cluster, it gives you a speed of 10 Gbps. 10 GB per second is the network AWS offers. It's very fast. All right. So coming to your Hive tables, partitions, and buckets. Okay, so Minnie has a question. Also have option of S3 or Redshift or DynamoDB. Yes. So AWS. So we also use. I mean, S3 is used a lot in our case also. For some of my projects, we are using Redshift. I mean, I am not working on that, but yeah, we do use Redshift also. DynamoDB we hardly use. Yeah, but Redshift we use it. AWS is very good. It has more features now. It has something called as a spot machine. It has something called as a fleet machine. Like it's good. All right, so we are talking about Hive tables. Now in Hive, there are two types of tables. Okay, see, whenever you create a table in Hive, when I say creating a table in Hive, creates a folder in HDFS, but at what location? At what location? All right, now this location is fixed. Whenever you create a table, Hive will automatically create a table inside the folder slash user /hive /warehouse. It's a HDFS location. So let's say I create a table, or let's say I create a table Edureka. All right. So it will actually create a folder inside this user Hive warehouse here. If I load data inside this table, it would be files inside this Edureka folder. All right. Now, if I drop this table, if I say drop table Edureka, the same your MySQL syntax. What will happen with this syntax is it will basically delete this Edureka folder from your warehouse. When I say delete, it will delete it along with your files. So basically deleting a folder, dropping a table deletes your data. So this is very risky. Okay, if you drop a table accidentally, your entire data is gone. Right? There is no backup at all. Okay, such types of table in Hive are called as internal tables. Internal, it is also called as managed tables. This means your Hive is managing your data. So when you load data into this table, it will move your file. When you drop this table, it will delete your file. So basically, Hive is managing your data through your commands, your SQL, your Hive HQL basically. Such types of tables are called as managed tables. The other type of table, there is one more thing. Let's say I already have some data. I have some data in my so Chaitanya says replicated data is also lost. Yes, Chaitanya, everything is lost. So when I remove, so it's basically triggering a command Hadoop fs-rm-r. So if I remove anything from Hadoop, it will delete the original thing along with replicas. Okay. Now let's say I already have some data in my HDFS, which is a different location. This is not a user Hive warehouse location. I can create a table on this folder also. Right? I can create a table on any folder outside my warehouse location also. That is also possible. Okay. Now let's say this test1 folder already has some data. And when I create a table which points to this test1 folder, this folder already have some data, so I don't need to load this table again. It will automatically recognize the data and read the data. Okay, so Shiv says I'm late. No issues, Shiv Prasad. So we were discussing about tables in Hive. Right? So if I already have a folder which contains some data, I can point my table out to this folder also. See, ultimately it's an HDFS location. So this is also possible. How do I point it? So in your create table syntax, you have a clause called as location. You can specify the location of data also. And if this location should always be a folder. right? Because it's ultimately a table. And if this folder contains data already, there is no need to load data in your HDF, in your Hive table. It will automatically show up the data. Again, if I drop this table, it will delete this folder also if it has permissions. So this is still an internal table or managed table. Let's say if I drop a table, I don't want the data to be deleted. Such tables are also possible, and such tables are called as external tables. Such tables are called as external tables. So Hive supports internal table and external table. So there are two types of Hive tables. What is the difference between internal and external? So if you drop an internal table, it will drop two things. It will drop the data and the metadata. Metadata from the HDFS, metadata from the metastore. If I drop an external table, it will drop only the metadata, not the data. My data would be untouched. So getting the difference between internal and external tables. Now which one to use when? It is just a matter of choice. There is nothing as internal table is optimized, external is not optimized. There is no question about optimized or fast access, because ultimately both these locations are your HDFS locations. Okay, it's just a matter of choice. If you are just using Hive for your entire processing, you can use internal tables. But on your data, if you want to use Hive also, Pig also, Java MapReduce also, other tools, then you prefer external tables. Because accidentally, if you delete your Hive table, data should not be gone. Correct? So this is a difference between, this is the types of tables available in your Hive, internal and external. Now what is the syntax of creation? So how do you create a table? So it's create table. I give a table name. Let's say Edureka. You define columns, just like your SQL. I say column 1, which is an int, column 2, which is, let's say, string, column 3, which is, let's say, big int, and so on. This is how you create a table in Hive. Now remember, I told you when you create a table, you should specify the delimiter upfront. Now it's a fixed syntax. How do you specify that? So you have to specify row format delimited fields terminated by. This statement is fixed. Row format delimited fields terminated by. And then you have to specify which is your delimiter. It can be a comma, it can be a dollar, it can be a tab, anything. Additionally, if you want to point it outside your warehouse to an existing HDFS location, you can say location and you can specify the location. All right, so she has a question. How about a fixed length file? Okay, so fixed length file, you cannot load that in a single table itself. So we also have a concept. We have a case of fixed length file. Okay, so Bhaskar has a question. Location is mandatory whether it's outside or local, right? No, Bhaskar, location is optional. If you mention a location, your table data can be outside. If you don't mention a location, by default, it would be created under your user Hive warehouse folder. Okay, so Abhilash says, is there a shell to run this command like in Pig? Yes, Abhilash, there is a Hive shell available. Okay, Rahul says, which file it will read? Which file as in? So basically this will create an empty table. Okay, you have to put the file in this. And you have to load the data inside this file. Okay, now answering Shree's question, right? Fixed length files. So basically, let me tell you what are fixed length files. So these are files which has your data having a fixed length and it does not have a delimiter. Let's say this is my employee name. Okay, this is my employee address. This is my, let's say, email ID. So basically, if you notice, there is no delimiter here, but I have a fixed length that my employee name should be 3 characters. My address should be 4 characters. My email ID should be somewhat in this characters. So we also get such files. So what we do is we create a table with only one column and we load this entire data in that column. Okay, so what we do in this case, just to give you an example, so I create table, let's say records. I give a column name, let's say record ID, and I specify it as string. Yeah, yes, Rahul, you're on the exact lines. Okay, then what we do is we create one more table, let's say EMP, which has my actual data, name, which is string, address, which is string, mail ID, which is also string. Then what we do is we write a query. So we load this file inside this table. We load this file inside this table. Then we use a query, insert into EMP, select, and we use substring methods. Okay, so 0 to 3 will give me, 0 to 2 is a fixed length, which will give me this 3 characters. Again, substring, address would be 4 characters, so 3 to 7. Substring, 8 to, let's say, 15. From records. Now it won't be as select, it would be just select, insert into table, table name, insert into table EMP, select, and give a query. When as select is there, let's say this EMP table does not exist. Okay, I don't create this EMP table. Still I can use this query. Inside, for that I can say create table EMP as, and then I can use this query. This is also possible. So the second statement, this statement will create the table also, will insert the data also. Create table as select. Same as Oracle. Yes, exactly. Okay, this is called as CTAS construct. CTAS, create table as select. This is possible in Hive also. So Chaitanya says select star into. Select star into. Is there a query like this in Oracle? I suppose it does not has. Oh, Sybase. No, it is, yeah, so similar to select star into if you consider Sybase. Okay, nah, so Hive and MySQL does not support this. Okay, select star into is not supported. You have to say insert into table and select query. Right? Okay, now how do you use Hive? So there is no demo in Hive actually. So let's take it. I don't think Hive is installed or not. Let me check. It should be there. It is. So just say Hive and enter. It will enter into Hive shell. Okay, now the same, it's just like MySQL. I can say show databases. These many databases are there. I can say show tables. Remember, if you don't, I mean, Hive by default comes with a database. The default database used by Hive, the name is default. The default database of Hive is default. So Rahul says for Hive also service needs to be started. No, so Hive is not a service actually. It's just a client, just like Pig. You don't need to start anything for using Hive. Just your your Hadoop cluster should be started. Your name node, data node, and your resource manager, node manager. Hadoop cluster should be started. Okay, because Hive will connect to the cluster. Okay, so I can create a database. Let's say I create a table. So let's say create table. Just to quickly give you demo. Okay, so she says, how do we know name of the tables of a database? Okay, so we can do something like this. If we want to see the names of a table of this data of, so let's say I say show databases. Let's say I use any database. Let's say I use the SAM. I don't know what database is this. So I say use SAM, and from here I say show tables. So this will show tables inside the SAM folder. So it has only 2 tables. Right? Okay. So Chaitanya has a question. So Hive does not work in local like Pig. No, Chaitanya, Hive does not. Hive always works with a cluster. Okay. So let me do one thing. Let me create a database. I'll create my own database. I'll say create database Hardeep. I'll say use Hardeep. Now this Hardeep is newly created, so there won't be any tables. Show tables, nothing. Right? After every query you get this okay, but show tables there is nothing. Now what I do is, let me create some data. So I will deal with this employee records only. I'll be having employee ID, let's say department ID, I say gender, and let's say I have salary. Employee ID, department ID, gender, salary. Employee ID, department ID. Just for demo purpose, I'll just write only 5 records. Okay, 6 records. So I create a file here inside my folder itself. Let's say I create a file input.txt. Okay, that's already there. Hive input.txt. I insert this data here. Right? I will place this Hive input to my HDFS. Hadoop fs input user at Eureka Hardeep. No such file. Oh, sorry. Okay, I'll just do a ls on Hadoop. Okay, now look at this very carefully. I have this file here. Now what I do is, on this table, on this file, I create a table. So I say create table. I'll just write the query here. Create table EMP, EMP ID as int, department ID as int, gender as string, salary as, let's say big int, and I have to specify it's a comma delimited file. I say row format delimited, fields terminated by comma. That's it. I run this query in my Hive shell. Right? So table has been created. Now, when I say table has been created, this means a folder named EMP should be there in my HDFS. I haven't given any location, so the location would be Hadoop fs-ls user Hive warehouse. Okay, so Bhaskar says, what if the file contains more fields than fields specified in the table? Okay, that is also possible, Bhaskar. So let's say your file contains 10 fields, but if you define only 4 columns, only the first 4 columns would be visible in your Hive. The remaining 6 columns won't be there in your Hive data. But if you go and cat your file, if you go and check your file, data is there. Hive won't show you that data because you haven't defined any column for that particular data. Yeah, only first 4 fields. Okay, so I do a ls on my user Hive warehouse. So if you notice, I created a database Hardeep, so it created a folder hardeep.db. So I do a ls on hardeep.db. Inside this, it will create a folder EMP. Correct? Why EMP? Because my table name is EMP. Now if I do a ls here, does it has any data till now? It does not. It is empty. Right? Because I have just created this table. I haven't loaded anything. Okay, it's empty. So if I say select star from EMP, no data. Now how do I load data? So I say load data in path. I specify the path user Edureka Hardeep Hive input.txt, the file which I had created, into table EMP. Okay, this is the syntax to load data. So if I just run this, okay, loading data. So see how fast it loaded the data. Doesn't matter if your file is a 1 KB file or a 10 GB file or a 1 TB file. Load data would be very fast because it is just a memory operation. Yeah, so Rahul says, is this internal table? Yes, it is internal table. Okay. Now look at this very carefully. So if you see, previously I had done a ls on this Hardeep, so I had this Hive input which I have loaded to my EMP table now. Now if I do a ls, on Hardeep, if you see that Hive input is moved, it is no more here. That is why what I meant by loading data is a move operation. So Bhaskar says, so you are maintaining the data in 2 places. One is the file, other is in the table. So Bhaskar, this will answer your question. So when I load data, it will move your file. Okay. Now if I do a ls on the EMP folder, which is there inside my user Hive warehouse, now that file is here. Hive input is here. Now if I do a select star, star from EMP, now I get my 6 rows. Now, so Rahul says if you don't want to move, okay, so that's for if you don't want to move, Rahul, then you have to maintain 2 copies. Then you will use a Hadoop command to copy that file from your original location to your Hive folder location. That's your EMP folder. You can use a Hadoop fs-cp. Okay, now if you see, my data is here. Now Minesh, to answer your question, if I just want to check a few rows, not the entire thing, so I can say select star from EMP. I can say limit and I can give a number. If I say limit 1, it will show me the first row. That's it. If I say limit 2, this will show me first 2 rows. All right. You can use limit just to check if it is properly loaded. So I didn't get that question, Minesh. Mean input. You don't have. You have not the output. Yeah, data is already moved. Okay. Good question, Shiv Prasad. So Shiv Prasad says, can we use grant command on the table to other database? So Shiv Prasad, such queries, security related queries like grant access to a user, revoke access, grant access to a database, security things, by default it is not supported in Hive. Okay. If you want to use it, there is one additional framework which you would use. It's not a part here, it's an advanced thing. There is a framework called as Apache Sentry. Okay, there's a framework called as Apache Sentry. With this Sentry, you can integrate Hive with Sentry and you can use all the security related commands. This was the reason why Hive developed Hive Server 2. Okay, Sentry cannot work with Hive Server. Sentry requires Hive Server 2. That's when the latest versions of Hive, you have Hive Server 2 and you can integrate that with Sentry. And Sentry gives you commands like grant access, revoke access, grant select, and all such security related queries. Yeah, that's a part of DBA. Right? We don't usually do that, but that's a part of DBA. Okay. Now I said every query you write in Hive triggers a MapReduce job. If I say select star from this, do you think it's triggering a MapReduce job? Okay, so Minesh has a question. How will I load into table without knowing format? So Minesh, you cannot do that. Okay, if you can load to a table once you know the format. So it's a big data problem in every Hadoop framework. You should know your data before processing. You should know your data before using. All right. So select star. It's not triggering any MapReduce job. Exactly. So Rahul gave the right answer. It is just like cat. It is just displaying the file. It is select star is reading the entire file, right? It does not need a MapReduce. It will trigger a MapReduce when you will do some processing. Select star is no processing. Let's do a processing. Let's say select count star. Now this will trigger a MapReduce job. See the logs. It created a MapReduce job. See starting job. It gave a job ID. See map percentage, reduce percentage. Okay, that's the output. Right. So whenever you do some processing, right, the Hive triggers a MapReduce job. Okay, such queries are also not. So let's say if you want to know how many functions are supported in Hive. For example, I used a function, right, count. So you can simply trigger a query show functions. It's a very huge list. Functions, okay. See the huge, it's a very huge list. Okay, so Bhaskar has a question. When you load the data into table also, internally it will be multiple blocks. Yes, Bhaskar, it would be multiple blocks. When I say when I load data, see my data is there in HDFS. Okay, so ultimately whatever is there in HDFS is blocks. That's why I told it is moving data, right? It is not creating duplicate blocks. It is just updating your name node metadata. Yeah, depend if file is very huge, if your file is 10 GB, it will definitely create blocks because ultimately it's HDFS. Okay, so Shri says retrieving one column instead of star from a table also triggers MapReduce. Yes, Shri, because if I say one column, that is basically you're triggering a where clause, right? Where clause will only happen if it runs a mapper, right? So still it will run a MapReduce job. Now if I just say show function, see how many functions are there. It's a huge list of functions. Like if I don't know how to use a function, let's say I don't know how to use this L case. I don't know what is this. So I can say describe function. I can give the function name. It will show me what this function takes as input. It takes a string and returns string with all characters changed to lowercase. Okay, so Shri has a question retrieving. Okay, Manish has a question. Many MapReduce create any output table. Achha, MapReduce create any output table? No, Shri. So MapReduce does not create any output table. For example, count star, it triggered a MapReduce, but it did not create any table. It will create a table if you say insert into table or create table as select. All right. Now a very important thing. Pay attention here. Okay. So what I'm doing now, I'm dropping my table. I say drop table EMP. So my table is gone. Now let's check that folder. Now let's check the HDFS folder. Damn, it's stuck. Okay. User hive warehouse hardeep.db. See, that folder is gone. AMP folder is gone. Right? So it has deleted my data. This is what is an internal table. Right? Getting what is an internal table. It has dropped my data. Now let's check what is external table. So what I do is I again load this file. From my local to my HDFS. Okay, what I'll do, I'll show you two things. I create a folder in HDFS, Hadoop fs-mkdir. I create a folder with the name, let's say EMP, or let's say employee. And inside this employee folder, I put the data. So what I have in HDFS now, inside my Hardeep folder, I have an employee folder, and inside this employee folder, I have that hive input.txt. Now I will create a table on this location. Okay, now how do I do that? So I can do that this way. When I said create table, after this I can say location user Edureka Hardeep employee. Now if you notice my table name is EMP, but my folder name is employee. It is different. Still this is possible because I am defining a custom location. Now if I run this from my Hive. Alright, I've created the table. Now what do you think? This table is empty or not? Is this table empty? I have freshly created this table. Right? So everyone says it is empty. Okay, but I am pointing this table to an existing folder, right? I am pointing this table to an existing folder. This folder contains data. This folder, yes, it contains data, right? It contains this hive input.txt. This means I do not need to load this table again. Though this table is freshly created now, but it is pointing to a folder which already contains file. That's why I don't need to use load data in path. Okay, I don't need to use load data in path. I can directly say select star from EMP. This will give me the data. You're getting the beauty of Hive, right? I don't need to load the data if it's already there inside that folder. And if I check this EMP folder, if I check it inside my warehouse location, user Hive warehouse and hardeep.db, it is still empty. It did not create EMP there because EMP I am not using the default location, which is my user Hive warehouse. I'm giving a location, explicit location to it. Right? So this is the beauty of Hive. What will happen if I drop this table now? If I say drop table EMP, what will happen? Will it delete this Hardeep folder or employee folder? Okay, so everyone says no. Shiv Prasad says yes. Masker says it's an external table. So the right answer is it is still an internal table. So if I drop it, it will delete this folder. Want to check? See, if I drop this table, I do a ls. No such file or directory. Hardeep and employee. If I just do ls on Hardeep first, it won't find that employee folder. It has dropped, it has deleted that. So this is still, though it is outside warehouse, this is still an internal table. Now I'll show you an example of external table. So I'll again create a folder. That folder I'll recreate, mkdir. I will put that file back. Okay, so Rahul says the employee alias, this information will store in relational database. Yes, Rahul. So this employee, the folder, the table name is employee. The location is this. The columns are these. The data types are these. All of this information is stored in a relational database. That's your metastore. Right? So I've recreated the employee folder. I've re-uploaded the data. Right? So my folder is here. I'm re-uploading the data. As Bhaskar says, how do we query the metastore? So Bhaskar, we cannot query. Right? We cannot query the metastore, and ideally you should never query it. And in real productions, you will never have access to the metastore. Only the admins will have it. Because if you play with it in such a way that your Hive can also fail. If you, let's say you update anything, your Hive may fail. Right? That's why we never access the metastore. Okay, so you say, so Bhaskar has a question, but if you want to know where the file location or structure is and other information, etc. Okay, so that's through a query, Bhaskar. So I'll tell you the query also. I'll give you demo of that now. Okay, so my data is here. Now, how will I create an external table? So this is the same create table syntax, just one keyword I will add here. Instead of create table, I say create external table. That's it. Now this will create an external table. Okay, so let me run this. This will already have data because my file is there. So if I say select star from this table, it already contains data. Now, Bhaskar, to answer your question, I can describe this table. So if I say describe EMP, just like your MySQL, right? This will give me the schema of my table, right? But what about the location? How will I know this table is internal or external? How will I know where it is pointing? For that, you can use a query describe formatted and table name. This will give you all the information available, like when the table was created, who created it, who is the owner, last access time, everything. See, so it is giving my description. Along with that, it is giving me database is Hardeep, owner is Edureka, create time, last access time, retention, location. See, this is my location. Table type, it's an external table. When you create an internal table, the table type is managed. Okay. See, my delimiter is a comma. It gives you information about a delimiter also. Okay. This all information it is fetching from your metastore, but you cannot access the metastore directly. All right. So you saw select star data is coming, and my data is coming from this location. Right. Now I drop my table. Drop table EMP. So my table is dropped. If I say show tables, my table is not there, but my location that is still preserved. Location is still preserved. This is the only difference between internal and external. External table, if you drop data, it will just drop metadata, not the actual data. Clear? Okay, so we have seen this already. External table we have seen. Load data also we have seen. Right? Count. So these are some queries. Count star, you can count distinct. So distinct also works, right? Some. So this is normal your SQL queries. Okay, you can group by and everything you can do. Okay, now managing outputs. So one way is I mentioned that you can use insert into table name, and you can give a query. So whatever the output of this query would be stored inside the result table. So this is one way where you can store the output of a query. Second way is, so if you want to use the first way, you should have this results table created. If you don't have this results table created, you can insert into a local directory also. So you can create you can create a directory, normal folder, and you can say insert override directory, and you can give a query. All right. You can insert override on your local also, that is from on the machine where you're using Hive from, or an HDFS directory also. Okay. Now if you see this output, now what do you think? What is this? What is this special character in between? What do you think? What it is displaying? So let me tell you, it is actually a default Hive delimiter. Okay. What is a default pick delimiter? It is tab. But default Hive delimiter, it's a very special character. Default Hive delimiter is a character Control A. Okay, Control A. The ASCII for this is 0x01. It's a very unique character. Okay, in documentation you will find this as caret A. Right? Now, why this unique character? Again, the same reason which I mentioned. If your delimiter is the part of your data, right? Hive cannot escape that. control A is a character which is very rare inside your data. Okay, that's why Hive chose control A. Okay, so if you see this, so control A can, your normal notepad cannot read this control A, so it shows a garbage character here. All right. So these are Hive scripts. Just like Pig, you can write your entire Hive. Let's say you have 20 Hive queries, you want to execute it sequentially. I don't want to use my shell. I can create a text. I can paste all my queries there, and I can trigger that script. Okay, how do you do that? Hive -f, and you can give the path of that query file. It is just like your MySQL. MySQL also has this option, so you can use two options. This is also stuck. This is also stuck. Okay. Okay, so Hive has two options. Let's say you want to execute a single line query, but you don't want to enter into shell. Okay, you want to execute a query, but you don't want to enter into shell. So MySQL also gives you the same option. You can say Hive -e, and in single quotes you can specify a query. For example, show databases. So this will give you the output of the query, but it will not enter into shell. See, it is not into Hive shell. Similarly, you can say Hive -f and give a path of a file which contains all your Hive queries. Right? That will also work. Right? Then these are joins. Okay, so Hive, it supports joins. It supports inner joins, outer joins, left outer, right outer, full outer, everything. Is there anyone who does not know what are joins? What are outer joins, inner joins? I hope everyone knows it. Great. Just one additional thing for joins. Hive only supports equi-joins. Right? Hive only supports equi-joins. This means when I join two tables, the condition on which I am joining should only be an equal condition. For example, table1.column1 equal to table2.column1. Right? I can just do it in this way. Yeah, so Minesh says yes, exactly Minesh, no less than or equal to. So if I join two tables, let's say my table 1 has ID. Let's say I have a customer table in which I have a customer ID. I have a transaction table in which I have a transaction ID and I have a customer ID. If I want to join these two tables, so I'll say select, this is a Hive syntax, I'll say select star from C join trans, let's say T on c.id, sorry, c.cust id equal to t.cust id. This is a join syntax. Same, it's just like MySQL. Right? The only thing to notice is this, inside this on clause, Hive will only support equal to. It cannot be this way or this way. This will only be an equi-join. Hive does not support non-equi-joins. All right, that's one thing to note. Now there is Hive UDF. Now writing a Hive UDF is very simple. It's just like how simple it is for Pig. It is that simple. You have to write it in Java. Okay. So for example, okay. So this is the same encryption thing which we had, same thing copied. Okay, it's not mentioned here. Okay. So I'll tell you how to write a Hive UDF. Okay. So again, you have to write a class which can be anything. Say my Hive UDF class. You have to make it a subclass of UDF. So what is this UDF? This is a Hive class. All right. And you have to override one method, and the method name is evaluate. All right. The return type of this can be anything, and it can take any number of arguments depending upon what you need to process. So let's say I pass it an argument. Let's say the string. I want to return a string itself. Let's say I'm writing a UDF to convert everything to uppercase. So how will I write it? So I'll simply say return input dot to uppercase. This is my Java method. That's it. This is my UDF. Nothing else. It's very simple to write a UDF. You have to just write one method evaluate, and you can overload this method multiple times. Let's say I want to write two UDFs. Okay, for second case, let's say I'm passing two integers. Let's say I want to return a sum of integer. I'm doing a sum. So I'll say return a plus b. That's it. So it's very simple to write a UDF. Okay. Now what you will do is you will convert this particular class to a jar file similar to pig, and there are few, and just like pig, right? When you were creating a jar for UDF, you were registering it. Same thing you have to do in Hive also. Just the query is different. So the query is you have to first say add jar, right? And then you have to create a temporary function. Temporary functions, then the next slide. You have to say create temporary function. You have to give a function name as, and you have to give your class name. And this de-identify, you can use it in your query as it is. Now one thing to note, just like pig, all the UDFs in Hive are also at session level. So when your session finishes, your UDFs are gone, right? That's prevalent from this syntax also. It's create temporary function. It's a temporary function. It's a temporary UDF. So if you exit from your Hive shell and re-enter into Hive, this function will no more be available. This de-identify function in this case will no more be available. So every time you have to recreate this function. You have to add the jar and recreate this function. Right. So this is how you will use insert into local directory, give a path and a query. This is HDFS directory. Right. Now let's take a 5-minute break. Right, and then we will discuss about partitioning and bucketing in Hive. Right, partitioning and bucketing in Hive. Right. Alright guys, I hope everyone is back. Great. So two important concepts in Hive. This is for optimization. That's partitioning and bucketing. So let's discuss what is partitioning first. Okay. Let's say I have an application, or let's say I have some data which I'm getting every day. Let's say the data is based on stock market. All right. Or let's say the data is based on, let's consider employee data. Okay, we have considering the same example from day one. So let's consider we have employee data. All right. Now I have three departments, 10, 20, and 30. All right. Now the data which I'm getting is very huge, and I have employees joining every week. So I have lots of data getting generated. Okay. Let's say overall data which I have up till now, let's say 10 GB. Okay. Now let's say on such data, if I want to query based on a particular column, let's say based on department ID, if I want to query, let's say if I say select something, so select something from this table, where I'm using a department ID. Let's consider out of these three departments, 10, 20, and 30, and from this 10 GB data, let's say 5 GB belongs to department 10, 3 GB belongs to department 20, and the remaining 2 GB belongs to department 30. That's a 10 GB file. Now if I do a select star from employee where department ID equal to 10, ideally I am just looking at this 5 GB file, right? I should just look at this 5 GB file. But as Hive is doing a full table scan, it will scan the entire 10 GB. Correct? So it will basically launch those many mappers which is required for 10 GB and not for 5 GB. Everyone agrees to this? Because Hive is doing a full table scan. Right? Now such cases can be optimized. Right? How it can be optimized? If I say Hive should not do a full table scan, Hive should just scan this 5 GB data. This can be achieved through partitioning. Right? This can be achieved through partitioning. Now what is basically partitioning? You can partition your table. Right? So there are two types of partitions to start with. There are two types of partitions in Hive: static and dynamic. Now let's first discuss what is static partitioning. Okay, so what you can do is when you define a table, when I say create table, in the syntax, I can say my table is partitioned. Right? Partitioned by, and I can define which column it is partitioned by. Okay, so in our case, let's say department ID. This piece is actually common. May it's static or or dynamic. This piece is common. Right? Whenever you define a partition table, you have to define the partitioning column also. Now what happens with static partitioning is when I say insert or when I say select. Okay, so before select, I would need to insert data, right? It's a freshly newly created table. So when I say insert into this data, insert into this table, okay, I can specify which partition to insert. I can say partition is department ID 10. And then I can insert only that file. I can load only that file which belongs to department ID 10. So I can, how will I insert? Either through a query or through load data in path. So I can say load data in path. I can give the path of those files which belong to department ID 10, partition into table name. Now what this will do, when I say partition by, now what this partitions will do basically is, what's my folder name? EMP. So directory would be user hive warehouse EMP. When I say department ID 10 partition, partition is nothing but a subfolder. Listen to this carefully. Partition is nothing but a subfolder inside my tables folder. So it creates a subfolder with the name department ID equal to 10 and places this file inside this folder. Okay, next time when I say load data in path, I want to load for department ID 20, it will create a folder, a subfolder basically, inside my tables folder and load that file there. Same goes for your department ID 30. Now what is the advantage you're getting with partitions? So for one thing to remember, you should partition on those columns, right, whose distinct values are very less. Okay, I cannot partition on my employee ID, right? My every employee ID is unique, right? So what this partitioning will do, let's say I have 1,000 employees, it would create 1,000 subdirectories, which is basically not even optimized. It's a worst scenario. You should only partition those columns whose total values are less. Okay, so though I have 10 employees or 10,000 employees or 10 million employees, I have only 3 departments. All right, so this would create less number of subfolders. Now what is the advantage of partitioning? In your query, or select, you're doing some logic, some algorithm you're applying here. From this table, as soon as you give the partitioned column in your query in the where clause, your Hive will take the advantage of partitioning and only scan this file or this folder. It will not even go and look what is there with this folder, what is there with this folder. So what you're achieving here, you're achieving that your Hive is not doing a full table scan. Getting the advantage of partitioning. What is partitioning? Any doubts about partitioning? Great. Okay, so Rahul says in load time, it's process the data. I didn't get that question, Rahul. Yeah, exactly. So when I say department ID equal to 10, it will move the data to that folder. Yeah, so she has a question, while splitting employee into partition, we have to do full table scan, correct? Okay, so so this will answer your question, Sri. Right? So we were now discussing about static partitions. Now static partitions. Now how does my Hive know this is a static partition? Because you're specifying the partitioning value also. See, my partitioning column is department ID, but when I'm inserting data, either both the ways I can use, I am specifying my partitioning column value also. That means I'm specifying that my department ID is 10 equal to, when I say equal to something, that is I'm specifying the value. This is what is meant by static. Okay, when I say department ID equal to 20, so what happens with static partitioning is this file which you're giving. Now, if this file contains data for 10 20, and 30, all the departments. Okay, this file is a hybrid mixed file. It contains data for all the departments, and you said load this file into partition 20. Hive will not even check the file. Okay, Hive will not check the file. Hive, though the file contains data for 10, 20, and 30 all, but as you have given a static partition, you have mentioned that the partition value is 20. It will go to this 20 subfolder and place that file here, which will basically return wrong output when you will query that. Okay, so this is basically static partitions. Now, when I say that, let's discuss the other thing. Let's say dynamic partitioning. Let's say my file is still containing all the data for 10, 20, and 30. But I don't want to use static partition. I want to use dynamic partitioning. Now what happens with dynamic partitioning is you don't define this equal to. Okay, in such cases, your Hive will automatically read this file. It will segregate department ID 10, put it in the department ID 10 partition. It will segregate department ID 20, put it in the 20 partition. Similarly for the 30. So your Hive itself is processing your file while loading it. That is dynamic partition. Now for processing, for dynamic partition, there's one thing to keep in mind. With dynamic partitioning, processing is involved. Load data in path does not trigger any processing. When I say processing, map reduce. When I say load data in path, it is simply moving the file. It is not triggering any map reduce. So if it's a dynamic partition, you cannot use this statement. You cannot use load data in path. The only way for using dynamic partitioning is you have to use this statement, insert into table. When I say insert into table and I give a query here, this will trigger a map reduce job. Okay, so let's say you have, how will you achieve this? So let's say I have data which contains all the files. So you need a staging table here. I will create a staging table, a normal non-partitioned table, employee ID, department ID, gender, and salary. I will create one more table, employee ID, gender, salary, which is partitioned by department ID. You will load the original file in this first table, which contains all the departments 10, 20, and 30. And from this table, you will load data into this table. The query would be insert into, I'll give the table names. I'll say this is EMP and this is PEMP, partitioned EMP. So I'll say insert into partitioned employee. I will specify partition. That partition is department ID. I won't specify equal to because I want to use static dynamic partitioning. I'll say select employee ID, gender, salary, department ID from EMP. This statement will trigger a map reduce job, and then your Hive would be able to read through your file, identify the unique departments, and create those many partitions. So if I have 10 departments, 10 partitions would be created. If I have 20 departments, 20 partitions would be created. All right. So that answers your question, Sri. Is there any doubt here? Yeah, so Minesh says PEMP does not have any department ID column. So when I say partitioned by, Minesh, this partitioned by also becomes the part of your column definition, table definition. One thing to note here is, may it be static partitioning or dynamic partitioning. All right, your partitioning column is always the last column of your table. right? Partitioning column is always the last column of your table. So if you look at this, if you look at the order in which I have selected department ID as last. All right. Now, one thing to note again, a difference between static and dynamic partitioning. Dynamic partitioning, the column on which you are partitioning should be a part of your data. For example, department ID. I'm partitioning on department ID. It is part of my data because Hive needs to scan through that, calculate how many partitions are there, and create those many subfolders. In case of static partitioning, you are specifying an equal to. So in case of static partitioning, your partitioning column may or may not be a part of your data. For example, if this is my data, employee ID, department ID, gender, and salary, I can partition by month also. Month, it is not there in my data, but I know that this particular file which I would be loading belongs to the month January, right? So I can partition by month, and I know I would be hard coding this value as Jan 17. Right? So in static partitions, your column, partitioning column may or may not be the part of your data. Right? So this is partitioning. It is basically required to reduce your full table scans. I can also partition, may it be static or dynamic, I can also partition on multiple columns. For example, in this case, I've partitioned by department ID. I can partition by gender also. I can partition by multiple columns also. The sequence of partition, whatever we have written in partition by, same sequence, there would be the last column. So gender, the sequence is last, so gender would be last. Right, so Rahul says, what if I want on a condition? No, Rahul, you cannot. Conditional, you cannot partition. So for example, you are saying that if salary greater than 10,000, you want a different partition? No, you cannot. You can only partition on columns, not on any condition of columns. It's only column level partition. Right? So it is suggested that you should not use more than 3 partitions in Hive. The reason is, the more partitions you use, your data would become more fine-grained, right? So let's say I have a 10 GB file. When I create 2 partitions, department ID and gender, how many folders would be created? What do you think? How many folders would be created? Yeah. So Minesh says 2. Rahul says n into n. Okay, so the right answer is it will create n into n. Right? Rahul gave the right answer. So for example, I have 3 departments and 2 gender. So 3 into 6, 6 subfolders would be created. And how that will look? This way. If this is the sequence, so my subfolders would be my employee folder, that's my parent folder, department ID equal to 10. Inside this, I would be having 2 subfolders, G equal to M, G equal to F. Similarly, for my department ID, 20 and 30 also, 6 folders. All right. Now, if your entire total file is 10 GB, all right. Now, if you have 6 folders, so ultimately my file has become small. Correct? My file has been broken into 6 pieces. Hadoop does not work well with small files. So Rahul says 20 GB. What is 20 GB, Rahul? I didn't get that. So a 10 GB file would be broken into 6 pieces. Right? Total file would be the 20 GB only. Sorry, 10 GB only. Now, so you're saying sum of file department plus gender. No, Rahul, it belongs to the same file, right? I have a 10 GB file which contains everything. It contains department ID also, it contains gender also. So that entire 10 GB file, if I partition it on the basis of department ID and gender, 10 GB would be broken into 6 pieces. If I don't partition on gender, my file would be broken into 3 pieces. All right. Okay. This way. Okay. So the more you partitions, the more small files you're creating. More small files, more mappers. Hadoop does not work with small files. I mean, it does work, but not optimized. So you should not partition. So you should be very specific, very careful while choosing which column to partition on, because here also steps in a question of your data skewness. If one of your partition value is skewed, let's say out of this 10 GB, 9.9 GB belongs to department ID 10, this 2 would create very small files. Right? So you should be very careful. You should know your data and everything. It comes with use. It comes with experience. It comes with looking at your data. Right? So this is partitioning. Now, on the other hand, Hadoop has one more concept called as, Hive has one more concept called as bucketing. Bucketing is very similar, and the use case is same like your merge join of your pig. Okay, it's same like your merge join of your pig. Bucketing is only used for join. Okay, so remember map side join, reduce side join. All right, so if you want to optimize join, if you want a fast join in Hive, what you can do is you can bucket the files on the join column. Let's say I have 2 files, employee ID and department ID. I have one more file, department ID and department name. Let's say both of these files are very huge. Okay, I want to join on department ID. What I can do is I can bucket my both the tables on department ID. Now what bucketing does, it does the same thing what your shuffle and sort does of your map reduce. Shuffle and sort, what it does partitioning, right? Shuffle and sort, what happens in shuffle and sort? It sorts your output. That's the first thing. Second thing, it uses the hash partitioner formula. It calculates the hash of the key, merge it with the number of reducers. Everyone is, aware of this, right? Everyone is, can recollect this, right? Yes. So bucketing is the same thing, right? So let's say if I bucket on department ID. So when you're bucketing, you have to specify how many buckets to use. So let's say I say bucket on, use 10 buckets. So what bucketing will do in Hive, it will break this file into 10 subfiles. So where partitioning was creating subfolders, bucketing creates multiple files. It does not create subfolders, it creates multiple files. And how it creates multiple files? Basically, as many department IDs are there, it calculates the hash code of the department ID, merge it with the number of buckets. Not the reducers, now there is buckets. Right? So this first case will create 10 files. Second case will create 10 files. If I use 10 buckets. Now, if I'm doing join and map reduce, if I'm doing a reduce side join, it is doing shuffle and sort year once. If you bucket, basically you are pre-processing this step and this step. All right. Now, if you join these two tables which are already bucketed, all right, so it's very simple for Hive to join. What Hive needs to do? Any guesses what Hive will do in a bucketed join? So let's say I create 10 buckets, or for showing it, let's say I show only 3 buckets. Bucket 1, bucket 2, bucket 3, bucket 1, bucket 2, bucket 3. When Hive wants to join a bucketed table, it actually just needs to merge the buckets. It will merge the bucket 1 from this file with this file, merge the bucket 2 from this file with this file, and same for bucket 3. So it's a merge join, same like pig. Such types of joins in Hive, these are called as SMB joins. Right? Such types of joins in Hive are called as SMB joins. If you're going for a Hadoop interview, if this is asked to you by your interviewer and you are able to answer this, he will ask you nothing else. He will simply select you. Right? Very few people know this concept. It's not there in the Edureka's syllabus also. SMB join, it stands for sorted, merged, bucketed join. Right? Why sorted? Because you're doing bucketing. Bucketing does shuffle and sort. So your buckets would be sorted. Right? So this we know. Why bucketed? Because we are using bucketing. And why merged? Because it is merging the buckets. So it is sorted, merged, bucketed joins. Okay, so Rahul says Hive also should have ordered data for bucket like pig. Yes, whenever you're bucketing, every bucket is sorted. Every bucket is sorted. Right? So it does sorted, just like pig. So it is similar to your merge join of your pig. So bucketing in Hive is only introduced for join optimization. That's it, nothing else. And partitioning it is introduced for reducing your full table scans. So both are for optimizing your queries. Right? So we will stop for today. Okay, so almost you have covered everything in Hive. Some advanced concepts are remaining. Okay, so ideally this was the last week from Edureka's end, but yeah, we would take some more days to finish our syllabus. Okay. All right, guys, we'll stop for today. Guys, it will be very helpful. It would be a favor actually. Can you all just raise one ticket with Edureka, a support ticket that we would be taking one extra, like 2 or 3 days more. Okay, that would be very helpful. I would try to finish everything by next Sunday. That's next Saturday and Sunday. If not, if something spills over still, then it may go till next Saturday. That's it. For 3 days max. So Kudantar, you have to just raise a ticket saying extra classes for incomplete syllabus. All right. That would be great. Yeah, Rahul, you had a question. Right. So if you have any questions, everyone, you can you can just send your questions, or others can drop off. Just please reminder, don't forget to fill in the surveys. All right. Thanks. Thank you, everyone. Yes, Rahul. Okay, so Rahul, you said in pig file should have sorted data, but should Hive have sorted data? So when you bucket a table on a particular key, right? Hive will, so bucketing will also trigger a MapReduce job. when you insert data to a bucketed table, that will trigger a map reduce job, and that will take care of sorting your data automatically. So you don't have to explicitly sort data. You have to create a bucketed table. When you insert into that table, it will automatically trigger a map reduce job and sort it. Great. All right. So Shiv Prasad says, can I have your mail ID so that I will send mail for any queries? Shiv Prasad, I'm extremely sorry. Actually, that's out of the protocol. But what you can do is, if you have any questions for me, you can raise a your Edureka support ticket, and you can just mention that questions for Hardeep. So it will automatically redirect to me. Okay, so Chaitanya says, will bucketing create multiple files? Yes, Chaitanya. That is why bucketing is meant for. So if you mention that bucket into 10 buckets, it will create 10 files. If you say 5 buckets, it will create 5 files. So partitioning will create multiple folders. Bucketing will create multiple files. All right. Good night, everyone. All right. Thank you.